You think space is nothing. You look up at the night sky, you see the darkness between the stars, and you think that's emptiness. Vacuum. The absence of everything. You imagine that if you could remove all the planets, all the stars, all the dust and gas, you'd be left with pure nothingness. Just empty space waiting for something to fill it. I spent years thinking about space. Years staring at equations, imagining what it would be like to ride on a beam of light, trying to understand what holds the universe together. And what I discovered changed everything. Not just physics, everything. Because space, the thing you think is nothing, is actually the most important something in existence. Let me tell you what I realized. When I was young, studying physics, everyone accepted Newton's law of gravity. Objects attract each other. The Earth pulls on the moon. The sun pulls on Earth. Massive objects exert forces on each other across empty space. Simple, elegant, and it worked. The mathematics predicted planetary motion perfectly. We could calculate orbits, predict eclipses, send rockets to the moon using Newton's equations. But there was something wrong with it. Something that bothered me deeply. How does gravity work? Newton himself admitted he didn't know. He said the objects just attract each other. Action at a distance across empty space. He could calculate the force perfectly, but he had no mechanism, no explanation for how the sun, sitting here, could reach across 150 million kilometers of vacuum and pull on Earth over there. What's doing the pulling? How does Earth know the sun exists? If space is truly empty, truly nothing, then how does the force get transmitted? I couldn't accept it. I refused to believe that objects could influence each other across true nothingness. There had to be something there, something real, something physical occupying that space and transmitting the force. And then I figured it out. Space isn't empty. Space is a thing. A real physical thing that can bend and stretch and carry energy. And gravity isn't a force transmitted across space. Gravity is space. Gravity is what happens when space itself has shape. This was the most difficult idea I ever had. It took me nearly 10 years to work it out properly, to get the mathematics right, to understand what it really meant. But once I saw it, once I really grasped it, everything clicked into place. Let me show you what I mean. Imagine space as a fabric. I know everyone uses this analogy and it's imperfect, but stay with me. Think of space as a flexible, stretchable fabric extending in all directions. Now place a massive object in that space. A star, a planet, anything with significant mass. What happens? The fabric bends, the space curves. The massive object creates a depression, a well, a distortion in the geometry of space itself. Now imagine a smaller object moving through that space. It's not being pulled by the massive object. Nothing is reaching out and grabbing it. The smaller object is simply following the straightest possible path through space. But space itself is curved. So the straightest path through curved space is itself curved. The object moves in what looks like an orbit, but from its perspective it's going perfectly straight. It's just that straight lines in curved space don't look straight from the outside. That's gravity. That's what I realized gravity actually is. Mass doesn't pull on other mass. Mass curves space, and objects move through that curved space along the paths dictated by the geometry. The sun doesn't pull Earth. The sun warps the space around it, and Earth moves through that warped space. Earth is falling, constantly falling, but falling through curved space, so it goes in a circle instead of crashing down. You're doing the same thing right now. You think you're sitting still, held in place by the floor beneath you, but you're not still, you're trying to fall. The Earth has curved space around itself, and you're trying to follow that curvature, trying to move along the straightest path through that curved space toward the center of the Earth. The floor prevents you. The floor is pushing up on you, stopping you from following the natural geometry of space. When you feel weight, when you feel the floor pressing against your feet, that's not gravity pulling you down. That's the floor pushing you up, preventing you from following the path that curved space wants you to follow. You're not being pulled, you're being stopped from falling through the geometry. This was the key insight. Gravity isn't a force, gravity is geometry. But here's where it gets really strange. If space can bend, if space has shape, then space must be something. It can't be nothing. Nothing doesn't have properties. Nothing doesn't bend or stretch or carry information. Space is a physical thing, as real as matter, maybe more real than matter, and it has structure. I realize something that still amazes me. Space and time aren't separate things. They're not independent. They're two aspects of a single structure. Space-time. one unified fabric. And mass doesn't just curve space, it curves space-time. It bends both space and time together. This means that near a massive object, time runs slower. I know how absurd that sounds. Time is time, right? A second is a second everywhere, but it's not. Time is part of the fabric, and when the fabric curves, time curves with it. Near a massive object, where space is highly curved, time is also highly curved. Clocks tick slower. Processes happen slower. Aging happens slower. This isn't speculation. We've measured it. Clocks at the top of a mountain run faster than clocks at sea level because they're farther from Earth's mass, in less curved space-time. GPS satellites have to account for this. Their clocks run faster than clocks on Earth's surface because they're in weaker gravitational field, less curved space. If we didn't correct for this, GPS would drift by kilometers per day. Near a black hole, where space is curved so extremely that it forms a pit you can't climb out of, time slows to a crawl. An observer falling into a black hole would experience time normally from their perspective. But to someone watching from far away, the falling person would appear to slow down, to freeze, to take infinite time to cross the event horizon, because time itself is so curved near the black hole that it nearly stops. Space isn't empty. Space is structure, and time is part of that structure. Together they form the stage on which everything happens. Except it's not a stage, it's a participant, an actor. The fabric itself is dynamic, responsive, alive in a sense. But I'm not done. Because if space is a fabric that can curve, then space can also ripple. When massive objects accelerate, when they move violently, they disturb the fabric of space-time. They create ripples, waves propagating outward at the speed of light. Gravitational waves, distortions in the geometry of space itself traveling through the universe. I predicted these in 1916. The mathematics of general relativity required them. If space-time is a dynamic fabric, if it can curve, then it must be able to wave. Just like water. If water can be still or curved, it can also ripple. Same with space-time. But I never thought we'd detect them. I said so explicitly. I didn't think gravitational waves would ever be strong enough, or our instruments sensitive enough to actually measure these ripples in space. The effect is so tiny. When a gravitational wave passes through you, it stretches space in one direction and compresses it in another by an amount smaller than the width of an atomic nucleus over distances of kilometers. Impossibly small. But they did it. In 2015, 100 years after I predicted them, scientists detected gravitational waves from two black holes colliding over 1 billion light-years away. They measured space itself stretching and compressing by less than 1,000th of the width of a proton. And the measurement matched my equations perfectly. Space rippled. The fabric of reality itself waved. And we heard it. That was one of the most profound confirmations of general relativity. Not just that gravity exists, but that space is real, physical, something that can carry waves, that can vibrate and oscillate and transmit information. Empty space isn't empty. It's a medium, a substance, a thing with properties. Now let me tell you something even stranger. Something that took me years to accept. If space can curve and ripple, if space is a dynamic fabric, then space can also expand. The fabric itself can stretch, not expanding into anything, just expanding. More space appearing between points. The distances growing larger even though nothing is moving through space. When I first worked out the equations of general relativity, they predicted this. They showed that the universe couldn't be static. Space itself had to be either expanding or contracting. The fabric couldn't stay still. It had to be dynamic. I didn't believe it. I thought it was a mistake. The universe was obviously eternal and unchanging, wasn't it? That's what everyone believed. The idea that space itself could be growing, that the universe could have a beginning, was too strange, too radical. So I did something I later called the biggest blunder of my life. I added a term to my equations, a cosmological constant, a kind of anti-gravity that would exactly balance the tendency of space to expand or contract, keeping the universe static and eternal. Then, a few years later, astronomers discovered that distant galaxies are moving away from us, all of them, in every direction, and the farther away they are, the faster they're receding. Space itself is expanding, the universe is growing, and if you run the movie backward, if you trace the expansion back in time, everything was once in the same place. The universe had a beginning. My original equations without the cosmological constant predicted this perfectly. I had the answer in my hands, and I threw it away because I couldn't accept what it meant. But here's the fascinating part. That cosmological constant I added and then removed, it might actually be real. Modern observations show that the expansion of space isn't just continuing, it's accelerating. Something is pushing space apart. We call it dark energy, and the simplest explanation is the cosmological constant. The term I added, removed, and called a blunder turns out to describe something real. Even my mistakes pointed toward truth. That's how powerful the mathematics was. But let's come back to the question of what space really is. Because I've told you space isn't empty. Space is a fabric. Space can bend and ripple and expand. But what is it made of? I don't know. Nobody knows. I spent decades trying to figure this out, trying to understand what the fabric of space-time actually is at the deepest level. Is it continuous? Infinitely divisible? Or is it made of discrete units, tiny chunks of space that can't be divided further? Does it emerge from something more fundamental? Or is space-time itself the fundamental thing? I never answered these questions. I'm not sure anyone has. But here's what we do know. Space has properties, measurable properties. It has geometry. It has curvature. It can carry energy. It responds to the presence of mass. It's not passive. It's not a background stage where things happen. It's an active participant in the physics. When you move, you're not moving through empty space. You're interacting with the fabric of space-time itself. You're following geodesics, the straightest possible paths through a curved geometry. Your motion is determined by the shape of space around you. When light travels, it's not traveling through nothing. It's propagating through space-time, following the curvature. Bending around massive objects, we see this. We observe light from distant galaxies, bent by the gravitational fields of closer galaxies. The light curves around them, following the curved space. We call it gravitational lensing. It's a direct observation of space being curved. Black holes are regions where space is so extremely curved that nothing, not even light, can escape. The curvature becomes so intense that it forms a closed surface, an event horizon, a boundary in space-time that you can cross going in, but never cross going out. Not because something is pulling you, because the geometry itself is so warped that all paths, all possible futures lead deeper in. Space isn't empty. Space is geometry. And that geometry is dynamic, curved by mass, rippled by acceleration, expanded by mysterious dark energy, and it determines how everything in the universe moves. This is what I figured out. This is what kept me awake at night for years. The realization that reality isn't objects sitting in empty space. Reality is objects and space together, interacting, influencing each other, inseparable. Matter tells space how to curve. Space tells matter how to move. That's general relativity in one sentence. That's the entire theory. Simple to state. Extraordinarily difficult to understand. But once you see it, once you really grasp it, you realize that everything you thought you knew about space was wrong. You thought space was nothing, a container, a void, the absence of things. But space is the most important thing. It's the fabric that connects everything. It's the medium that carries gravitational waves. It's the structure that determines motion. It's the entity that expands, carrying galaxies apart. It's something, not nothing. And here's what still amazes me. We can feel this. Not directly, but we experience the consequences every moment. When you throw a ball, it follows a curved path. You think that's because gravity is pulling it down. But what's really happening is the ball is moving in a straight line through space that's curved by Earth's mass. The curve you see is the projection of a straight path through curved geometry. When you feel yourself pressed into your chair, you think that's gravity pulling you down and the chair pushing you up. But what's really happening is you're trying to follow a geodesic through curved space-time, and the chair is accelerating you away from that natural path. The chair is pushing you up through curved space, and that feels like weight. When you watch the moon orbit Earth, you think you're seeing Earth pull the moon, but what you're actually seeing is the moon following the straightest possible path through the curved space-time created by Earth's mass. The moon is in free fall, weightless, following the geometry. Everything is following geometry. Always, there is no force of gravity. There's only the shape of space, and that shape is determined by where mass is, how it's distributed, how it's moving. I figured this out by thinking about acceleration. I realized that standing still in a gravitational field feels exactly like accelerating upward in empty space. If you're in a closed room with no windows, there's no experiment you can do to tell whether you're standing on Earth's surface or accelerating upward at 9.8 meters per second, squared in deep space. They're identical, physically equivalent. That was the key insight, the equivalence principle. Gravity and acceleration are the same thing. And if acceleration is just a change in velocity, a change in motion through space, then gravity must also be about motion through space. Which means gravity is geometry. It took me 10 years to turn that insight into proper mathematics. 10 years of struggling with tensors and differential geometry and equations that didn't work until suddenly they did. But when I finally got it right, when the equations came together, they were beautiful. The most beautiful equations I ever wrote. And they worked. They predicted things Newton's theory couldn't. The precise orbit of Mercury, which had been wrong in Newton's theory. The bending of light by the sun, which Newton's theory didn't predict at all. The gravitational redshift of light climbing out of a gravitational well. The slowing of time in curved space. All of it fell out of the mathematics naturally. Space isn't empty. That's the answer. That's what I discovered. Space is a dynamic, curved, four-dimensional fabric that responds to mass and energy and momentum. It's as real as anything in the universe, maybe more real, because everything else exists within space, moves through space, is shaped by space. You can't remove space and be left with objects. Objects and space are inseparable. They're aspects of the same thing. The universe isn't things in space. The universe is space-time, one unified structure. And we're patterns in that structure, ripples in the fabric, curvatures that know they're curved. When I realized this, it changed how I saw everything. I stopped thinking of myself as separate from space, moving through an empty void. I started understanding that I'm part of the fabric. My mass curves space around me, tiny curvature, insignificant but real. I'm not in space-time. I'm an event in space-time, a region where the geometry does something interesting. You are too. You're not in the universe. You're part of the universe's geometry. Your presence curves space. Your motion follows geodesics. Your experience of time depends on where you are in the curved structure, and the space between you and everything else. It's not empty. It's never been empty. It's full of structure, geometry, curvature, potential. It connects you to everything. The same fabric that's curved by your mass is curved by the sun's mass, by every star, by every galaxy. We're all embedded in the same structure, all part of the same fabric. Space isn't nothing. Space is everything. And once you see that, once you really understand it, reality is never the same. That's what I discovered. That's what shocked me, and it should shock you too.